Okay, guys. I'm going to explain the switches on the stepper motor driver. So you can see here I have these switches marked SW1 through SW8, and if you read on the stepper motor driver, it tells you what exactly to switch on and off. So here you can see on my stepper motor I have a 3 amp stepper motor. So that's the 3 amp limit. So I don't want to go, if I look at this first table, it'll tell me my current peak. I don't want to go above 3 amps. So I want to set everything to 2.84, which is just under 3 amps. So it looks like S1 is going to be on, S2 is going to be on, and S3 is going to be off for me. So if you look at the side here, the down position is on. So my dip switch here, 1 and 2 are on, and SW3 is going to be off, which is on, off. So there we go. Then the fourth dip switch is going to be SW off for half current, on for full current, and I want full current. So you can see SW4 here is on for full current. Then what I've done is set the resolution. So this is really up to you. It doesn't affect anything other than how quickly your motor turns and how big the steps are. So you can see here I have a 1.8 degree stepper motor, which is 200 steps per revolution, and you can just get that by dividing 360 by 1.8. So you can set your resolution here. Let's say I go for this top one, 400 pulses per revolution. That's going to make my motor spin pretty quickly for each pulse, because it's going to take less time. It's going to take 400 pulses to make one revolution. If I turned it up to like 25,600, it's going to take 25,600 steps for one resolution. So you can imagine if I turn my Arduino code speed up a lot, it's still going to move really, really slowly versus the 400 steps per revolution. If I turn my speed on my Arduino code up, you can see it's going to move a lot quicker. So I've set it currently to off, on, off, on. You can see 5, 6, 7, and 8, off, on, which is, it looks like 4,000. Sorry, on, off is what I read that wrong. On, off. So you can see that when I flip the switch here, it moves slowly. Okay, so if I set the resolution lower, let's say I want 1,000 now. It's going to be on, off. So I'm going to try to do this with the camera, holding this camera. So it's going to be on, off. So I just push that switch down. Now all of them are on except for 8, which is off. Now if I turn it on, watch what happens. See how much faster that moves? That's because I went from 4,000 steps per revolution down to 1,000 steps per revolution. The other thing that affects the speed of your turn is your Arduino code. So you can see here, I've set my speed to 1,000. This is just simply the delay. This doesn't really correlate to the speed of your driver. This is just something that says, okay, I'm going to send a high pulse and then wait 1,000 microseconds, and then send a low pulse and then wait 1,000 microseconds and set a high pulse. So what happens is your motor driver interprets those pulses on, off as a time to take a step. And so if I turn this value down, let's say I go down to like maybe 100 now, and I upload that to my Arduino. You can see, boom, it's done. Now, when I turn this on, and again, I've adjusted my resolution down to 1,000 on my motor driver. now it actually tries to go too fast, and we don't want that. So let's set our resolution back up. So on our motor driver here, let's go up to 5,000. So off, off, on, off. So there, I've set this off, 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 on, off. So now I've got speed of 100 at 5,000 resolution. Let's see what happens. So I go ahead and flip this switch, and you can see that's moving pretty quickly, but it's still smooth. So that's it.